Hi, this is Mr. Barr, and today we're going to take the roots of non-perfect numbers. In yesterday's video, we prime factored things, but the video before that, we were taking the square root using a calculator and getting crazy decimals. Well, now we're going to do it without the calculator and not getting crazy decimals. So roots of non-perfect numbers. So our goal is solving equations using roots. That's what we're actually trying to get to. And I need this tool so I can work with distance and motion. Things like Pythagorean theorem and quadratic formulas. Pythagorean, you know. Quadratic formula, you'll learn next year. Do you want to be able to find the distance between points? Do you want to know how a football travels through the air? Both of those require understanding square roots. So yesterday, let's get our title here. So our name, and our title is Roots of Non-Perfect Numbers. Roots of non-perfect numbers. So what do I mean by a non-perfect number? Well, let's start with what I mean by a perfect number. So we know that the square root of 49 is 7. This is a perfect square. 7 times 7 is 49. But other numbers are not perfect, like the square root of 40. I could, you can't see it, square root of 40. I could use a calculator and get an answer, but I'm not going to use a calculator. I'm going to do another method to get an answer. It's not going to be a decimal answer, but it will be the square root of 40. So how do I do this? First off, I prime factor 40. Well, a 40 is a 2 times the 20. Actually, let me follow my notes. A 2 times the 20. And a 20 is a 2 times a 10. And a 10 is a 2 times a 5. So I prime factor out the square root of 40. And what am I left with? That's what I'm left with. The square root of 2 times 2 times 2 times 5. This is 40. 2 times 2 is 4, times 2 is 8, times 5 is 40. So this is the same thing as the square root of 40. This and that are the same thing. Now what I'm going to do is I'm going to pull out the pairs. I want you to look at these guys right here. What is 2 times 2? Well, 2 times 2 is 4. And do you know the square root of 4? Yes, the square root of 4 is 2. So this little piece of it right here, I can bring out front. Because I know the square root of 4. 2 times 2 is 4, so I bring it out like that. So what I'm looking for are twins. The square root of 49 is 7 times 7. You see those 7 times 7? What's the square root of 7 times 7? Well, it's 7. See the twins? I bring them out front. So I'm looking for twins, and I bring them out in front of the radical, or the square root. So here, my final answer would be 2 square root of 10, because 2 times 5 is 10. So I prime factor it, and I pull out the twins. Pull out pairs. Let's do another one. The square root of 54. We'll do this one in our notes. I start by prime factoring it. Well, 54 is, what's that, 6 times 9? And 6 is 2 times 3, and 9 is 3 times 3. So I prime factor the number inside the radical. So what do I have? 2 times 3 times 3 times 3. So look at these two numbers right here. What's 3 times 3? 3 times 3 is 9. What's the square root of 9? 3. And we'll clean it up. The answer is 3 times the square root of 6. Now the same logic will work with cubes. The cube root of 24, let's do it in our notes. It works the same way. I start by prime factoring. That's 2 times 12, which is 2 times 6, which is 2 times 3. There it is, prime factored. 2 times 2 times 2 times 3. Oh, you know what? I needed to put that cube on it, didn't I? It's a cube root, not a square root, it's a cube root. Cube root. When I was doing square roots, I was looking for twins. Now I'm looking for triplets. Do I have any triplets? I do. Right there. 2 times 2 times 2. Well, that's 8. And what's the cube root of 8? The cube root of 8 is 2. I cross those guys out, and I have 2 square root of 3. That's it for the notes. Let's do a couple practice ones here. You do not have to put this in your notes if you're watching this live. I'll be having you do these and then tell me your answers. I am looking for my pen. There's my pen. Okay. So 50. What makes a 50? Where am I? There I am. 50. I could go with, so you're going to prime factor this. I'm going to go with 2 times 25. I got all sideways. So 2 times 5 times 5. Now I'm going to look for my twins. I've got a pair of 5s right here. Those guys come out in front because 5 times 5 is 25 and the square root of 25 is 5. They're gone. And what am I left with? 5 square root of 2. How about the square root of 200? Square root of 200. Let's break down that 200. 200 is 2 times 100. And 100, you know what? I'm going to cheat a little bit. I know 100 is 10 times 10. And actually, that's the pair that I'm going to be having here. So I have the square root of 2 times 10 times 10 Let's go find some twins. All right, those two guys are twins. 10 times 10 is 100. Square root of 100 is 10. Comes outside. These guys are gone. Goodbye, goodbye, goodbye. And I'm left with 10 square root of 2. Do another one. Ah, the cube root of 81. Okay. So we're not going to look for twins. Now we're going to look for triplets. So 81 is 9 times 9, which is 3 times 3 times 3 times 3. There it is, prime factored. We need to go find some triplets. So right here, there are some triplets. 3 times 3 times 3 is 27. The cube root of 27 is 3, so the triplets come out. These guys are gone. And I'm left with 3 cube root of 3. Oh my goodness, cube root of 3,000? Let's see what happens here. Cube root of 3,000. Let's break down to 3,000. That's 3 times 1,000. And 1,000 is actually 10 times 10. That's 100 times 10. There's my triplet right there. Let's pull out our triplets. Right? 10 times 10 is 100, times 10 is 1,000. Cube root of 1,000 is 10, so they come out in front. These guys are gone. And I'm left with 10. Oh, you know what? I should have been putting my little cube on all of these. Cube root of 3. 10 cube root of 3. And there are the answers to all of them. All right, hey, thank you for watching. Have a great day.